Hello, everyone. Good morning, good afternoon, good evening, wherever you may be around the world. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs & Stratton Energy Solutions. With me today is Nathan. Hi, Nathan.
Hello, Daniel. Hello, everyone. Good morning from California.
Couple of housekeeping items before we get started. This is going to be a NABCEP accredited course. So at the end of this training, we're going to pop up our email. Please email us your full first and last name, spell it out for us, and we'll be sure to issue those credits. Again, if you want NABCEP credits, you have to email us at the end. The chat has been disabled, although we do have the Q&A available. So please put in the questions, the comments, anything you might want to share with the whole group, and we'll address those as we go along. One exciting thing coming up is the InterSolar. InterSolar is going to be coming up I think, next week, Nathan.
Yeah, I'm
We're
looking forward. I'm heading down to San Diego on Monday, and I'm really looking forward to Intersolar.
It's probably a short notice, I know, but if anybody has not gotten a free pass to go to InterSolar, we do have free passes available. There's a QR code there. If anybody's on this talk that is attending, be sure to stop by the booth. We'll be sure to give you a wristband to a special event that we're hosting. So come on by the booth. The booth number is 3340. We're over by the Solar Games. Another great event coming up is NABCEP. That's coming up later in March out in Reno. So excited for both of those as well. Well, today's topic is going to be about whole home backup. Traditionally, when we've done whole home backup, we've used a generator. We've used a transfer switch that will then isolate us from the grid and then start up the generator and then power the whole home, right? That's how we used to do it. I think right now, and Nathan, maybe you want to comment too, with the advent of more powerful hybrid inverters, such as the Sol-Ark 15k with the 200 amp pass-through, which we're going to talk about today. Additionally, also less expensive, more powerful batteries like our 6.6 stacking battery. The idea of doing whole home backup with energy storage batteries is now becoming much more common, much more popular option as well. Of course, you can combine the two as well and have a much more resilient system as well. When you do
Yeah,
combine them,
Daniel,
yeah,
I mean, the flavor or the market of backup is certainly changing, right? And I think that that's one of the reasons for this talk is to make those that are, typically aware of doing our installations with our product of this change. And the fact is that battery-based systems are more dynamic. You can integrate more things with them. You can get payback by integrating options like solar. You can do things like grid arbitrage. And we'll get into some of that a little bit in this talk, but for the most part, I think what we're trying to share is how things are changing, and you can end up with just like the electric vehicle market is taking off, the electric backup market is taking off, but there are still options for hybrids. And I know you're going to mention that in this talk that you can put a generator together with batteries, have shorter run times, less fuel usage, and get more mileage from a generator and an ESS system. So it's an exciting time, and there's a lot of innovation happening, and we are part of that innovation. And we're going to get into that, and it's just fun to see things progressing the way they are.
yeah, that's absolutely right, Nathan. These battery energy storage systems aren't just sitting there waiting for the backup. They can be more of a grid interactive appliance. Nathan, another thing that to mention, I think that makes these possible is when we talk about whole home backup, we're really talking about off grid. You're going to off grid the home during an outage. And with some of the smart load output capabilities of the Sol-Ark and other hybrid inverters, that we can do load shedding at appropriate times. So that's another key as well. So we do offer generators. We've been making generators for a long time. We offer the smallest one. Actually, that 10K needs to come off this slide, Nathan. We're no longer making that. Our smallest now is the
Absolutely does.
13K. These
Yes.
are both natural gas and propane. The 18, 22, and 26 actually do have certification for what I'll say is non-emergency use. So they're essentially allowed to be in an off-grid situation as long as you have an energy storage system associated with it. The 18 and 22 have the ability to run the same power output, whether it's on natural gas or propane. We call that technology NG Max as
What do
well.
you mean by the same power output, Daniel? You mean no D rating?
Yeah, exactly. A lot of people don't realize when you run a generator on natural gas, maybe a 22K generator is only going to put out maybe 18.5 kilowatts. We've optimized some of the ignition timing, the exhaust manifold, the intake manifold, so that if you're running on propane or natural gas, you're still going to get that nameplate rated as well.
And that's not true with many of our competitors. So we're pointing this out. So you're comparing apples to apples when you're showing customers, products and options for backup, for whole home backup.
Additionally, we do have liquid cooled generators running up to 200 kilowatts. So, Nathan, I think it's a good idea just to kind of level set so we're all on the same page. I know we show this slide a lot in our talks, but Nathan, just kind of walk us through this and what are we looking at here? What is a battery energy storage system?
Yeah, absolutely. So we just looked at a transfer switch in generators, right? And talked about how that's kind of that's been the standard for whole home backup, right? The power goes out, your transfer switch switches over, starts up your generator, and you've got backup from your generator for the whole home. Well, it's a little bit different with inverters. The transfer switch is actually built into the inverter. So there's a big amount of savings right there that you get when you switch over to a battery-based system. The inverter also has the ability to take in grid power to charge those batteries up. And then if the grid goes down, that connection to the grid will be severed. So we're not backfeeding power from the inverter into the grid. But really, at the heart of your system, you've got to have a battery that's capable of a large number of cycles, right? So that you're getting a long lifetime out of it. You've got to have a battery that's capable of the power output and the amount of energy storage necessary to give that backup time. But more than that, the inverter can also integrate other sources of fuel, and that's where things get different, right? Solar is a great example, right? Putting solar panels has just dramatically reduced in cost since I got into this industry. So 20 years ago, solar panels were probably 5-6 times what they are now, depending on, retail rate now. You're seeing solar panels at 25 cents a watt, right? That's the cost of a glass window. And it's, of course, there's an installation cost associated with that, but the return on investment for solar panels now is very low. It's short, and it depends obviously on many factors. But you can also integrate a generator into your system as well. And if you're looking for longer run times, if you're in a location like maybe that gets hurricanes or that gets fires, it might take a transformer station down, a place that might be off for a week, and you don't have solar, you might want to integrate a generator. And if you do have solar and you're a place with inclement weather, or maybe you're in a place far in the north where you don't get a lot of solar in the winter, having a generator as a backup to be able to charge that battery, especially for off-grid. So there's this, you've got this hybrid inverter, which has a charge controller integrated into it, can take solar into it, can take generator into it. It can control by starting and stopping the generator, the flow of power. And so now we're looking at multiple sources of power, kind of a diversification of your home electricity system.
Yeah, yeah.
We're going
And
to get on
Nathan,
those details.
yeah, Nathan, another thing about photovoltaics is that not only are they coming down in price, but the technology every year is improving with half-cut cells, with warranties. Not only the product, but the power warranty are increasing. I'm excited to walk around with you at InterSolar, and we'll go check out some of the latest and greatest from some of our solar partners as well. This is a great example of what it can look like for a whole home backup using energy storage. We have a Sol-Ark 15k there on the right. On the left is one stack of our batteries. Nathan, you mentioned it earlier that you need to be able to have enough power, right? The capability to start the loads that are on in the home. We also need to have enough energy or fuel reserve to have the juice or the fuel tank to run those loads for the appropriate amount of time, right? To get us through the night. That way, during the daytime, the solar can recharge the battery. Nathan, this is more of a marketing photo, though, right? What might we see in more of a real life install?
Well, I've installed ones that look similar to this, Daniel. But what's one of the things that I think is missing is Energy Track. So our Energy Track gateway could be on there that gives you monitoring into a lot of detailed information about your individual battery modules. What you're looking at on the left side of the screen are 3 different battery modules there, part of the SimpliPHI 6.6 stack. Now, you could have multiple stacks for a home. I know of homes in Florida that have 4 stacks. In fact, there was one here in my town that has 4 of these stacks of batteries. You also are looking at conduit there. That's just a rendering of, it looks like 3/4 or 1 inch conduit, which you're going to want to run with these stacks because you're running much larger battery cables for the low voltage DC, the 50-volt DC. You're going to use 2-inch conduit for that. And so the conduit size is a little bit off, but in general, this clean, nice look is what this 6.6 stack looks like. And I'm a big fan of this battery. I'd like to say it's new, but I think we've had them in the field for 9 months now, and we're having tremendous success with these batteries. Just excellent overall performance. I think it's the best battery that Briggs and Stratton SimpliPHI has ever made. Um, and so, you're looking at this, but you might have a generator that integrates into it as well. And so there are going to be additional attachments. You're not looking at the panels here. I mean, typically the panel is going to be inside the garage, but depending on the location, you might even have an outdoor panel. So a little bit of difference here, but that battery does look about like it does in the field. Really easy
Yeah.
to mount. You can mount it on the floor or the wall, and we'll talk about that.
Yeah, and looks do matter a lot. Another thing, Nathan, is that we've really designed this battery for the North American market. And I think that's given us some success, driven it, is that we do recognize that we are going to run 2-inch conduit, and we provided those 2-inch knockouts. So you're not having to punch anything. It makes it really quick, really easy to install. So like we had said, we're really excited to partner with Sol-Ark. There are other hybrid inverter opportunities out there, and we do have compatibility with some of those and more coming as well. A lot of other companies are hitting the market with those hybrid inverters, replicating the success that Sol-Ark has done. But we're really excited with Sol-Ark. They're a great US-based company. Same here with Briggs and Stratton. If anybody's ever up in Milwaukee and they want to visit our factory, I'll be happy to arrange a tour of that factory so you can look at the history, the 115-year history of Briggs and Stratton and what Nathan and I are doing to maintain that legacy every day. So, Nathan, a lot of times we would usually do a partial home backup, but the name of this talk is whole home backup. So we're really going to focus on that right-hand side image today.
I think you're
And
right. I think historically we were doing partial home backups because the technology just wasn't there. Not having, big pass through, not having these large relays that can actually switch the power of the whole home from grid to battery to, using solar or potentially even generators. And now the availability of inverters like the Sol-Ark 15k, and the 15k was really the first one on the market to do this, right? And that's Sol-Ark has got that legacy as, coming out with this inverter 2018, 2019, it hitting the market and backing up whole houses with that 200 amps of pass through. So traditionally, historically, what you see on the left is what you would have with a solar and battery system. Batteries like lead acid batteries, not really capable of delivering that power output for the whole home unless you had a very large bank. Now with lithium batteries, you're looking at double, triple the number of cycles, so triple the lifetime. You're looking at greater power density, so a smaller size battery pack can output enough power to actually back up your whole home. That's what you were seeing with our 20 kilowatt hour stack there. And I'd say that we don't really need to segregate core and critical loads for the house. That doesn't mean people aren't still doing it. Absolutely, people are making do with a little bit less, and just realizing that they are going to be more proactive in their electricity consumption during an outage. So on the right side of the screen, notice on the left side of the screen, if you disconnect from the grid, if you get a power outage, what's going to happen? Well, the inverter is going to isolate its power feed from the main panel, and you're going to essentially have just the battery, the inverter, the solar, and the core loads backed up, isolation. The difference on the right side of the screen is that connection to the grid is coming directly from the service entrance. You're going from the service entrance through your disconnect, through your meter, and then your disconnect. And then the inverter is then all of the loads of the house are kind of fed through the inverter. And so in a grid outage, the anti-islanding of the inverter will disconnect from grid, and then it'll allow batteries and potentially solar and potentially a generator to continue to feed the loads in the house.
another thing we don't have to do, Nathan, is water the batteries anymore, right? We don't have to have jugs of
Yep.
distilled water next to it as well. So thank you, Nathan, for breaking down the two as well. This is what it might look like for a whole home backup system. We do have at the core of the system is that hybrid inverter there. We do have grid coming down from the top through the disconnect, feeding, passing through the inverter to our backed up loads panel. As Nathan mentioned, that will be able to isolate itself from grid and then use the energy stored in those batteries on the bottom left to power and back up the loads. And if we do have solar, we don't have to have solar. There is opportunities to do just backup. You can absolutely bring in solar, and we're showing some rapid shutdown devices there. I believe those are AP Smart rapid shutdown devices.
Yeah, those are AP Smarts that's there. We're also showing, there's an AC disconnect that we're showing there. I do want to mention that Sol-Ark has that PV disconnect built into the side. That's what that black switch on the left side of the inverter is. So as long as your inverter is installed outdoors, you wouldn't need that extra disconnect there. Sol-Ark's really thought of a lot in terms of you could actually power the Keep Alive signal, the transmitter, for those AP Smarts right out of the Sol-Ark accessories bar, and you'll be showing that in a bit. Let's go to the next one. And now we're looking at a system where we've actually integrated a generator. So very much the same. We're showing different rapid shutdown modules there. But similar setup, we're showing a different type of our batteries. That's our Boss 12 battery cabinet. That's much bigger than that 20 kilowatt hour stack, which is about, a little over two times as big. And we can actually offer heaters with these batteries, right? So if you've got a cabinet and you're in an environment that's fairly cold, even if you put this, cabinet in your garage, you might want heaters if you don't have a heated garage. And so we can offer that with that Boss cabinet that's there. And we're showing it with a 22K generator integrated in, right? And so if you have long duration backout. What I like about this configuration, Daniel, I mean, we're showing the solar feeding into the inverters. But we're showing two paralleled inverters here. And what's the advantage there?
More power.
Absolutely. More power. We've got, instead of being limited to 200 amps of pass through from the grid, now we can pass 200 amps through each of those inverters. And after the inverters, right, we would then parallel up the signal, the AC power coming out of those inverters, and then feed that into a single 400 amp panel if that's what the house has. We have the ability to bring in as many batteries as we want on almost any inverter. You're not limited to the batteries on your inverter, but you need to be able to make sure the inverter has the ability to charge them, right? And here we're showing 90 kilowatt hours of backup that will run the average house for, the better part of a week. And we're also looking at a DC combiner here. So I like this because it's important to know anytime you parallel inverters, you have to use a combiner for your batteries. You cannot bring one battery stack into one inverter and a different battery stack into the other inverter. They have to be operating at the same voltage.
Yeah, and Nathan, I would also mention you don't necessarily need to have two inverters only on 400 amp service homes. There could be an opportunity where it's just a 200 amp service to a home, and you might need the two inverters. When they do go into an off-grid mode, we only have about 12,000 watts from batteries each. So if we add two, we have 24 kilowatts of continuous.
Right.
And then, and then additionally, we can surge as well. So opportunities to do that as well. And noted on the disconnect for the solar, and we'll be sure to get rid of that on the next time around. So bringing the generator in has been a big topic. Nathan, I was out at Wisconsin at the Renew Solar Expo, and there was a lot of questions about integrating generators into energy storage systems. There's two fundamental ways to do that with the solar. I think the cleanest and simplest way is to bring the generator in on the gen port. All Sol-Arks and a lot of the hybrid inverters are very similar in their architecture. They have a bidirectional grid port, a load out port, and then additionally a gen out port, which can also function as a gen input as well. So we're showing here the generator. Now that looks like a portable generator, but it could be a portable or a standby as well. And then we can control that generator using the two-wire signal to start. We're going to show you here in a minute how to adjust the value at which the state of charge of the batteries will either trigger that generator to start or to shut off as well. And again, you don't need the transfer switch. Another opportunity to bring in a generator is also on the grid port. Sol-Ark, I believe, is one of the best inverters on the market for integrating generators. And here's kind of the example why, is that if you do have a generator on the grid port and the solar is producing, you don't want to go in there every time and maybe disable grid cell, right? The idea that you're going to start backfeeding the grid. Once the generator starts, the Sol-Ark, as far as the Sol-Ark is concerned, it sees the grid there. It may start to try to start backfeeding the generator. You don't want to see a generator run backwards. The Sol-Ark, though, is smart enough to know that it sees the generator there by recognizing that when it does start to backfeed, the voltage and the frequency of what it would expect during a nominal backfeed event isn't there, and it will then prevent and curtail that backfeeding. Now, Nathan, though, if we do have AC coupled solar, and this is a great example why we might want to bring in a generator on the grid port, what that allows us to do is it frees up the gen port. But if we do that, Nathan, there's some concerns we though have, right?
Yeah, so I mean, one of the things that you can do here, Daniel, is when you have AC coupled solar, essentially what happens inside the inverter when it's got an AC source and an additional AC source like micro inverters or AC coupled solar through a string inverter that's brought in through the gen port, it essentially it parallels those inside, right? And generators are grid forming devices, and AC coupled inverters are grid following. The problem is that when they see the presence of grid and you have enabled grid cell, what can happen is those AC coupled inverters can try to lead the phase of the generator. And in doing so, they can send power back to the generator and potentially damage the alternator of the generator. So we don't want AC coupled solar ever backfeeding the generator. There's no value for that, right? We're not gaining gaseous fuel back by running that generator backwards, right? So you can do a few things. And Sol-Ark recommends that that you just program your generator to only run at times when the solar is not going to be available, nighttime, for instance. With Briggs & Stratton, we have these lockout modules. So if you're using one of our transfer switches, you can just install a line voltage lockout module like shown there. That's only about $100, $150 for that part. And that will basically, anytime that generator is running, we could shut off that AC coupled solar. If you don't have this, there are other relays that you can get, and Daniel and I can provide with a recommendation. Now, the PSP product that Daniel is showing there on the screen is programmable. You can program it to turn off anytime that generator has started. And that comes in 60, 100 amp, and there's actually even a 200 amp version of that product. And that product's a couple $100, a little bit more expensive than our line voltage module. But essentially that will disconnect your AC coupled solar to prevent backfeeding of a generator. I'm a big fan of leaving that generator port open, or using that for AC coupled solar in a retrofit, and making these extra efforts to make sure that we're not backfeeding the generator. But
Yeah, Nathan, you mentioned that it's usually uncommon, right? If the AC solar is producing, that means it's charging the batteries, and there should be no reason that that generator is coming on, though. But perhaps maybe it's early morning or a cloud passes over.
Yeah, absolutely. So those are those conditions you're worried about, right? That the generator is started because the batteries get a little bit low, and all of a sudden that cloud cover passes, it gets sunny out, the generator is running, and now there's excess solar and it's trying to backfeed the generator because the battery state of charge is below that generator start. And once that generator starts, it will run until those batteries are fully charged, right? That two-wire signal to start doesn't just cut it off as soon as the AC coupled solar is there. So what we're showing you are some ways around those challenges. And hopefully in the future, we mentioned about technology improving. Hopefully, we'll see some developments with software that can more easily take care of these problems.
Yeah, let's use the generator to charge up maybe 60 or 70% and then shut it off, knowing that the sun's going to come up in a few hours and we can top off the charge using solar. I
Absolutely.
think, Nathan, this just goes to show that Briggs & Stratton Energy Solutions is not only an expert on batteries, but also generators. And if there's ever any need, questions on any of these designs, reach out to us. Our email is going to pop up. Feel free to call us and we can help you with any of your design challenges. This is a great looking system, right, Nathan?
Yeah,
On the
I love
right.
this system. I'm looking at, this is just a really nice install where the customer kind of went out, got their own heavy duty metal cabinet, has done a nice parallel system with two 12K Sol-Arks there. So you've got 18 kilowatts of continuous power, 9 kilowatts each, 12 if you've got solar integrated into them. But you know, you're looking at a very nice install here. Let's see the next one.
Yeah, I like those conduit bends on the left. And here's, yeah, two more examples, right? Nathan, and Nathan, these are using our PHI batteries, correct?
Yeah, these PHI batteries are actually very useful for large systems. You know, if you're doing a large system, it's very easy to couple these. And you see they've got these custom bus bars that are used to combine these. There's a battery combiner that you can't see there in the middle. It's a little bit in the back. That's one of the Briggs and Stratton combiners. It's a 2,000 amp combiner, right? 2,000 amps of power out of those batteries can come through that. And that's feeding, I think I count
Two,
eight
four,
different,
yeah.
yeah. And I think I can see the edge of another inverter. So it looks like eight inverters there on the left side of the screen. And then on the one on the right, I know that that's 7. And these are powering, in the case of the one on the left, I know that's powering a village. So this is a battery room at a community center. The one on the right, I know is on an island in Connecticut. And these are just nice examples of how you can use the PHI batteries to achieve large paralleled systems. And speaking of our batteries, right?
Yeah, yeah.
Yeah.
So the PHI battery, that's the one we've been making for a long time. It's a always SimpliPHI Power has always leveraged lithium iron phosphate batteries. I think there's still definitely a time and a place for that battery on the left. That battery on the left, the PHI battery, doesn't have closed loop communication capabilities. I know that's a hot topic now, and we have a lot of inverters that can communicate. But if you have an old Xantrax or an old Trace or some older equipment that doesn't have closed loop communication capabilities, you don't necessarily need to buy a more expensive battery that has the battery management system with that closed loop communication capabilities. So
You
that
know,
PHI
Daniel,
battery is left. And then 24 volts too, right, Nathan?
yep. Yeah, and you might have a completely functional system, right? Your inverter might be meeting your needs. You've got your cabin or your off-grid home, and everything meets your needs, but those lead acid batteries are reaching the end of their generally shorter life than lithium, right? And this one is nice because it can come in that 24-volt option, and it's really a lead acid replacement. It gets you up to lithium, gets you those large number of cycles, really high quality LFP battery pack inside there. And that battery is an excellent choice. And if you do want to add, kind of some smart monitoring, you can do things like add that Victron Smart Shunt and still have monitoring without having to talk to each of the individual BMSs. That being said, we realized there was the desire in a lead acid replacement to have a smart BMS in there. And the SimpliPHI battery comes with the same high quality battery pack, comes with a 15-year unlimited number of cycle warranty. And that's also a nice option for lead acid replacement, where you've got not just the same high-end battery pack, but you also have advanced monitoring now with Energy Track. You can monitor individual batteries. You get a lot of information there. And then, of course, the 6.6 stackable battery. Daniel, I mean, I can say so many good things about this battery. For me, it's how quickly this installs. I can have this stack up on the wall in 30 minutes and begin working on the conduit. And you mentioned earlier about having those knockouts ready. Some of the first generation of these batteries, the controller didn't have the knockouts, and so you'll still need to punch for the 2-inch conduit. Not a huge problem, but it does take extra time. So we're trying to continuously refine and improve our products to reduce installation time, because we know that saves installers money, it saves customers money, and you could, essentially do 2 of these in a day if you get them down.
Yep.
I can't say enough for how much I like this battery. Just performance wise, we just don't have, we haven't had any major issues in the field. We're just having some minor issues. Maybe a installer gets their wiring wrong. So that being said, when we tell installers to go out there and install these communicating batteries, what do you always recommend they take with them?
A network tester, Nathan. And that's,
Absolutely.
I think it goes to show that how software and communications are becoming more and more important, not only in our everyday life, but also in these battery storage systems as well. That being said, Nathan, you don't need the BMV 712 Victron shunt. with some of these communicating batteries because it's built in. There's even a
Yes.
fuel gauge on top as well. So
Yeah, and what I
I
like
just,
about these systems, Daniel, I've got the 6.6 stack. I had the SimpliPHI batteries on a home that I sold. I could monitor them remotely. I could check on my system, see how the solar is doing, and it's kind of fun. I can do the same. I finally got, a bit of solar up on my shop roof here. And I can check in on the batteries, see how they're doing, see if they're charging, see what their temperatures are, see what the loads are. And I've discovered I've got a big pine tree here that's shading me during certain hours of the day. So it's nice to see all that stuff. It's not necessarily essential to some homeowners don't care about that, and that 5 battery gives a nice option. What's on the right side? What are we looking
the
at?
right side is one of our high voltage modules. So unlike the batteries on the left side, which we all run in parallel, we can run these batteries in series to build up that DC voltage, which allows us to run more commercial applications, such as three-phase 208 or three-phase 480 systems as well. So again, those are more of a custom design, or we do have packages as well, but reach out to Nathan and I, and we can address some of those. Nathan, you brought up something earlier, and I know we're going to keep going here, but having whole home backup, I think is key to have an app that shows the homeowner what their battery reserve level is, so they can make some behavioral adjustments so that they're not draining their battery through the night. So having those apps, knowing what they're looking at, they don't have to walk out to the power shack and look at the old battery monitor as well. I think it's key. Nathan, before we go on, I want to just mention, is anybody still seeing 24-volt battery systems out there? Please put it in the comments. Also,
Yeah,
if
and
you,
I just want to mention we've got several dozen people attending here today, maybe 30 or so of you. I haven't seen any questions, so would like to see those questions. Let's keep getting into the meat of it, Daniel. Let's get into
yeah, absolutely.
programming.
So Nathan, we're looking at our high voltage as well.
Yeah, this is a high voltage build where you're looking. I think this one is actually integrated with Oztech inverters. So Oztech is a US brand inverter. I think it's out of Ohio. And they make high-end inverters for both 208 and 480 native three-phase power. So we have that option there. I do want to point out that Sol-Ark makes a 30K and 60K high voltage inverter lineup that has integrated solar charge controllers built into it. And I also want to point out that if you want to do three-phase with 208 with low voltage inverters, you can absolutely use the 6.6 stacks with 12Ks or 15Ks to do 208. 480, you're going to need one of the high voltage inverters. And Verlon asks, hey, we're going to get a copy of these slides, and the ample is absolutely. Luis asks, can any of these batteries be combined with a Growatt SPF DVM inverter? Well, good news. We have completed integration testing with Growatt, and we will be announcing Growatt inverters as one of our inverter choices with our closed loop communications built in here in the next month or two. So absolutely, Growatt inverters are on our list. And we'll get more information out. In fact, we're going to be doing a training on Growatt once we finalize that. So yes, slides will be coming out, and Growatt inverters are one of the ones that's kind of on our list of integrations.
Nathan, you had mentioned these batteries have a lot of cycle life. I'm kind of blown away by the number of cycle lives, especially even at high discharge rates, right? These are not the C over 20 or the C over 10 discharge rates of our lead acid battery days. We can
Well,
C
these
over
are also
2.
100% depth of discharge.
Yeah, exactly. And so we're able to utilize the full capacity, although we still maybe recommend maybe a 90% DOD before hitting that low battery cutout voltage. But absolutely, we can get 6,000 cycles. If you're cycling that daily, that's something like 16 years. And that is at 100% depth of discharge. That is at over C over 2
And
rate.
that's why we put that plus in there, Daniel, right? Pounding on these batteries in a lab, you're getting these kind of cycle lives. But we understand that most customers are going to be a little bit more gentle. They're not going to put the pedal to the metal like we do in the lab to be able to get these things done quickly. Most customers are much more gentle on their systems. And that's why we say 4,500 or 4,500 plus cycles, because you can get more than that. Daniel, partly we're including this slide just so everybody has it as a reference, but a single, this 6.6 battery that I was, giving my praises to. And I don't say that just because I'm an employee. I just really like this battery, but it's a high power output battery. It's capable, a single module is capable of 6.65 kilowatts of power. That's a lot of power coming out of a single battery module. A two stack can do 10.65 kilowatts. There's a little bit of limitation inside the controller based on trying to balance the power output of the individual batteries, and a three stack's capable of 14 kilowatts of continuous power output.
Which is perfect for a Sol-Ark 15k, which
It'll draw
requires
12.
12,000. So we got a little buffer there.
Yeah, absolutely. And then, you can do multi-stacks up to 6 stacks, so 18 of these batteries to power an office building, or I've seen them in large homes near me. All right, let's keep going through. I do want to highlight these. These are 9540 certified, 9540A safety tested. These we can put large numbers of the Phi and the SimpliPHI batteries in these, and these also come with we can integrate heaters. It's a special order, but if you're in a cold environment, we can integrate heating solutions for these.
And I will mention that the 6.6 battery does have a 9540. It has that DC certification with use of other inverters as well. We can
Daniel,
even,
before you
yeah.
go on too far, Luis asks, my location has lots of wind and sun in the Bahamas. Has there been a system using wind solar hybrid? And actually, the answer is yes. Daniel and I see a few of them come through. Wind is typically a little bit more expensive of an option than the solar is, but absolutely, there's even a wind setting in the Sol-Ark. You can bring that in through the gen port. One of the things I mentioned, if you have a larger wind system, is you do have to have a power dump. So you would need to have a load bank to take care of excess power if that wind gets too high and exceeds the ratings that the Sol-Ark can take in.
Yeah,
So yes, there are some examples.
we used to see a lot of wind. I remember reading my old home power magazines, and you would see micro hydro articles and wind power. But I think Nathan, you had mentioned with solar being 25 cents a watt, with no moving parts, no heat dumps, that it's really gone away a lot. But I'm excited to see some pictures or stories about people integrating them still. Nathan,
Daniel
what are we
Verlin
looking at here?
asks, will
Yeah.
the battery pack and the Sol-Ark handle the inrush current of an AC when running solely on batteries? The answer to you, Verlin, is that the battery can surge to 300 amps for a single stack. The Sol-Ark can double its power output for 10 seconds. So you can go from 12 kilowatts up to 24 kilowatts to get you going. And it'll also do, Daniel, correct me if I'm wrong, and I'm kind of hesitant to say this. I think it'll do 100 amps for 0.1 seconds. I have seen some 4-ton air conditioners that without any kind of soft start that will pull 130 amps. So if you've got a really large air conditioner, you might want to put a soft start on it. And I've seen Engineer 775, for instance, Daniel took a 135, 130 amp 4-ton air conditioner, dropped it down to about 30 amps. With a soft start. So you might have a soft start. Those start in the range of 250, go up to about 500 for soft starts on larger air conditioners. But yes, for the most part, 3-ton air conditioner or less, the Sol-Ark should be able to handle that surge.
Yeah, I would recommend looking at look at the locked rotor amps. And I would also mention that as newer air conditioners and heat pumps are coming to the market, a lot of them are inverter driven, so we're not seeing those big surges as well. But absolutely adding a soft start is a great strategy, Nathan.
Yeah, and those single split phase systems, they really draw a large amount. For 3-phase systems, you're not getting that pull. But that when you first are starting those air conditioners, they have a start winding in them that draws heavily. And by adding that soft start, you're able to reduce that by using capacitors. So Daniel, this system that we're looking at here, this can come in heated options as well. We're looking at, that's a 12K Sol-Ark that's there.
It's an old one, yes.
Yep, showing the example of SimpliPHI batteries, which can come with heated options. So if you want a cabinet that's about 25 kilowatt hours, a kind of a complete system with weather enclosure, we can even integrate locks onto that, etc. And then we're looking at the different examples of Sol-Ark inverters that are out there, the 8K, the 12K, the 15K, which we're spending much of this talk on, and then the native high voltage 3-phase systems, the 30 and 60K. And we'll be sharing that presentation.
So Nathan, you mentioned it. We need a minimum number of batteries in order to support those Sol-Arks, right? Because we don't want to discharge the battery too quickly.
Yeah, absolutely. Now you can limit how much power the Sol-Ark will pull from a battery bank. So you can go in and manually set the settings to limit the power output of your inverter. But again, if you're buying an inverter that has a certain power output, you want to meet that. And to get that power demand, our Amplify and Phi batteries run at a C/2. That means they can output half their power in an hour, right? Half their total capacity in an hour. The 6.6 battery and the 4.9 batteries, well, the 4.9 is also a C/2 rating, and the 6.6 is a 1C rating. The communicating batteries will automatically request the Sol-Ark to limit the output power. And so there's a minimum number of batteries in order to attain the full capabilities of the inverter. We are showing it for the 15K there. So this gives you an example of the minimum number of batteries you would want to safely meet this power output and have a long lifetime in your system. Here we're talking about single or double stacks with a 15K, and these are our two most common options for whole home backup. We're seeing either a single stack with a 15K for smaller overall systems. Daniel, we looked at my electricity bill recently, and I think we computed it was something like 32 hours that a single 20 kilowatt hour stack in a 15K would run my home.
Yeah, and how did we come up with that, Nathan? Right? We looked at your power bill, your electric bill. We took how many kilowatt hours you used in a month. We divided that by 30. That told us how many kilowatt hours you use in a day. And then
Yep.
we looked at you, like you said, we're able to then do a little math and then figure out that a battery would last X number of
Yeah, we've
hours.
got
So
a 20 kilowatt hour battery there. I was using about 16 kilowatt hours, 15 kilowatt hours in a given day. And so that would back me up for about, somewhere approaching 30 hours over a day. Um, the average customer uses a little bit more than me. And I think the average backup time for a single stack with a 15K is about 15.4, 15.5 hours. The two stacks of batteries in a Sol-Ark 15K is a more common option. Of course, you could parallel more inverters too, but the more common option and what I like about our system with the Sol-Ark is you can independently scale the battery capacity from the inverter, right? So instead of having like one of these all-in-one systems where you got to buy another inverter because the battery is part of it, you can do these independently, and you got a lot of customizability here. You could do two stacks. You could do, 4 2 stacks if you really don't have that height available in your installation location. And so we are showing here the recommendations for your home runs, your DC battery cabling here. When you're installing within conduit, the recommendation from us is dual 1-aught battery cables for a single stack. And if you've got double stacks, run two 2-aught cables. You've got 200 amp breakers, dual cable breakers in the Sol-Ark to protect those battery cables. And if you need to combine them into one because you've ran a single set of 4-aught for an open air single stack with a Sol-Ark 15K, we do sell those combiners. I think they're about $25 a set.
yeah, I think the 15K having the dual battery inputs, making having two stacks of batteries really easy. But Nathan, if we have more than two stacks, you had mentioned it earlier, we have to combine them.
Yeah, absolutely. And there are a lot of options for combining it. One of my favorites is the Victron system, and we'll show that a little bit later. In the top left corner, we've got a 4-stack of batteries that Larry Phillips Electrical did in my town. That's combined with two Sol-Ark 15Ks, and they use that midnight combiner box that's up in the upper left-hand corner, where you have the breakers you can see mounted on the outsides of that midnight combiner. And then you can have up to 10 different inputs coming into those DC combiner bus bars that are there. We're also showing here's another example of a 1,000 amp combiner with fuses instead of breakers, and this is a much cheaper option. So I've got 2 of these here in my shop set up with 4 of those Class T fuses. And I ended up using 250 amp Class T fuses, and so you can bring up to 4 stacks of batteries in with 2 of those devices, 6 stacks. So it's each device you can bring in 2 more stacks with, and they're stackable devices. So on the right side of the screen, you can see we've stacked them one on top of the next, on top of the next, etc. These Victron Class T power ends, they're $165 each. right?
Yeah.
Really low cost. Those fuses go for about $35 a piece. And so you can put together a combiner for 6 battery stacks, for $600. It's
Now,
low
yeah,
cost
no,
way
I
to do it.
love it, Nathan. Now, Nathan, we say here cable runs to individual stacks should be the same length. Why are we saying that? So what we're talking about is if we have these batteries and we're going to the Victron power in combiner, we want all of these lengths, battery lengths, cables to be the same length. Why would we want to do that, Nathan?
During high power outputs, you can lose a little bit of voltage on lines. And so the longer the line, the more voltage you use. So when you're rapidly discharging or rapidly charging, these small imbalances in the voltage that a battery sees at its terminals can result in less power output or input from that individual battery. And so to be able to properly balance the load across the batteries, what we need to do is use cables of equal length. And if you don't do that, you'll shorten the lifetime of the batteries with the shorter cables, and overall degrade the kind of aging of your system.
Nathan, I get this question though. Somebody has a stack of 3 and a stack of 2. And I think that just goes to show that, be able to
Yeah, yeah.
customize the system in the thing. So what are we going to do though if we got a stack of 3 and a stack of 2? Should they still be the same length?
Well, what you overall want is the overall resistance of that section of the circuit to balance with the overall resistance of the section of 2 batteries, right? And the more batteries, the more resistors you have in parallel, the more batteries you have in parallel, the lower the overall resistance is. So you would use a slightly longer cable, right, with the 3 stack of batteries, and use a shorter cable with a 2 stack of batteries, and that helps to balance that resistance, helps to balance out the power draw out of the 3 stack and the 2 stack. So I appreciate you sharing that here. And it does depend a little bit on the cable gauge that you're using. And if you want some help, reach out to our team. Our application engineers can help you design with the appropriate lengths to use. And obviously, it'll depend on the situation.
Yeah, and Nathan, you mentioned also the rate at which we're charging and discharges matters a lot. If we're just kind of slowly charging and discharging, it's not a
It's
big factor.
lower, much,
We're
yeah,
look
much lower effect.
Yeah, we're looking at the inside of a Sol-Ark 15k here. A lot of people are familiar with this. We're not going to spend too much time here, but again, the 3 different ports: the grid port, which can pull in grid or a generator as well, that load output, and then the gen port. The gen port isn't just for generators; it can also be a smart load output, which I think is really key. We can also bring in AC coupled solar. We got a load disconnect as well. Battery CAN bus. That's where we're going to plug in the communications down to the batteries. If we are going to parallel inverters and in a whole home backup situation, we may be doing that. We're going to use the parallel comms there. We got our MPPTs to bring in our solar, and then the dual battery inputs along with the DC breakers as well up top. Really
Yeah, we're
quick.
showing here, Daniel, this is an SimpliPHI battery, and we're showing how you would wire that communications wiring is key. You're daisy chaining your batteries. One thing I'll point out with this one is you need to have terminating resistors and open ports on a CAN bus. Those tell the CAN bus, the communication along the CAN bus, hey, this is the end of the chain, no more batteries to my left, right? And so make sure to have those terminating resistors. And then the connection, the final home run connection that goes to the inverter, just comes out of any one of the device ports of those batteries. So which normally, customers choose the one closest to the inverter to connect directly to the inverter. And you would do that in that port you're highlighting there, the CAN bus port on the inverter.
Yeah, and with the 6.6, right, the network terminator is built into the stack itself. It's in the base, so we don't have to worry about that. We talked about it earlier, but absolutely integrating a generator into a whole home or an off-grid home is key. It's something we've always done. Again, what we can do is run a 2-wire signal to start from the inside of the Sol-Ark using pins 11 and 12, and then we would run them into our generators. You're looking at the horizontal unit and that vertical 13K unit. Pins 4 and 5 would be where we're going to land that on that
Yeah, I think you
side.
misspoke there, Daniel. It's pins 7 and 8.
7 and 8.
11 and 12 are the rapid shutdown, and they're actually labeled, I think, BB on these inverters. But pins 7 and 8 are
Thank you,
ready to
Nathan.
go to your 2-wire signal to start, and that'll allow your inverter to automatically start up your generator when those batteries get low. So Daniel's showing the kind of the full control bar here. What those different pins are: 3, 4, 5, and 6 you'll always use. Those are the CTs that come with the inverter. And then BB, pins 11 and 12, you would use those always as well. Almost every jurisdiction is going to require a rapid shutdown button on the outside of the house to make sure you can shut down the inverter and the solar, given an emergency situation with first responders. And then that generator start relay, that's the normally open dry contact, and that'll connect with pins 3 and 4 in our generators. Let's keep going. We got about 10 minutes left. I want to make sure we get time for questions. I do want
Here's another engineer 775.
Absolutely. Practical preppers. So I have gotten asked this question just last week. Where can I get one of these templates? So if you search for practical preppers Sol-Ark 15k template, you'll get an 1/8-inch thick aluminum knockout template there, which allows you, if you do a lot of these, it's probably worth the money to get that. And that helps you get your positioning straight so you don't have any angled conduit running up to the inverter. And here's an example of a Sol-Ark 15K. This is a training wall that Daniel and I put together before one of our events. I've got this thing actually running in the shop right now. And we're pointing out here how you're going to program this when you've got batteries coming in. So let's go to that next slide. So once you enter the settings on the menu, you can either do this on your phone through the Sol-Ark app, or you can do this on the front of the Sol-Ark using the screen. For a single stack of batteries like you just saw there, it's 398 amp hours. You'll see the defaults of 100 amps, 185 amps for charge and discharge. So we're going to change those in a minute. But we do want to make sure we select that BMS lithium battery, and the default address for a SimpliPHI system is 00. Once we have that box checked, the inverter knows to communicate directly with the battery through the CAN bus loop. If you don't have that box checked, it will assume you don't have a communicating battery. So make sure that box is checked. And once that is, you can get into the settings. Now, best practice here, Daniel, would actually be to go through without the BMS lithium battery box and without the communications checked. And that's actually, put in the values for float, absorb, equalization, just in case you ever have an instance where you lose communications. You want to have those, the inverter will default to the manually programmed set points, and we can put those voltages in. What is float and absorb for our batteries, Daniel?
Well, those will be auto-populated. 54, right, is
For float? Yep.
Yep, and 56 for
Yep,
absorb.
Absolutely. So that absorption voltage is when you exit the bulk phase, which is the constant current part of the charge cycle, and you go into the absorb phase, the constant voltage part. And then float, if you do have a renewable source like solar, it'll just keep those batteries topped off at 54 volts. So you can program that in. That's below on the bottom right-hand side of that slide there. And like we said earlier, everybody's going to get a copy of this slide deck. So let's go ahead and go to the next slide. Here we're looking at the values which the Sol-Ark will respond on the discharge side. So let's suppose your Sol-Ark is running off of batteries. You've got no solar coming in. You don't have the generator starting up, etc. We've just got a regular discharge going here. And when the battery gets to 30%, that's when you start going to get a low battery signal. So the inverter will start beeping at you. Your battery's getting low. When we hit 20%, as we've got set on the screen, and these are changeable, what happens, Daniel?
The voltage starts to drop, not relative to the state of charge.
And the shutdown, right? The inverter is going to shut off loads. That's what shutdown means, right? And so in this case, right, we're showing a 30% low battery. That's just when you're going to get a warning from your inverter, your battery's getting low. And then the shutdown voltage is when you hit that voltage, the inverter will shut off the load output. So the house, you would lose power to the house, right? You would lose the loads. The inverter's still there. And then if you've reached that, and then the sun comes out and the batteries start charging, it doesn't just immediately turn the loads back on. What does it do? We have to get up to that restart percentage or restart voltage before it will turn loads back on. And that's to give the batteries a chance to charge up. Generally speaking, if the solar wasn't strong enough to power loads, then those batteries would just be discharging. And so to prevent a back and forth cycle, we normally recommend going 10% above your low battery. So let's keep going. Here are some options within the Sol-Ark, and we don't really have time to get into this, but we will get into this in the programming Sol-Ark slide deck. But we have some options for doing things like grid cell. You can limit how much power you'll send back to the grid. You can do limited power to home by allowing the Sol-Ark to use its CTs to monitor how much power is coming into the home and export that same amount of power back to your load panel. That's if you might have a separate load panel from your main load center of the house. So this would be more common in the 12K and the 8K.
We do have a link there to kind of get more detail on how to program this time of use setup as well.
Absolutely. Thanks, Daniel. And then, of course, in the grid setup here, most of our customers are going to be doing 122/40 split phase. I actually have 122/08 three-phase in my shop here, and you can easily switch the Sol-Ark between accepting, 208 leg-to-leg input or 122/40 leg-to-leg input, right? And so you have those options. This is a slide that talks about our cold weather options with our SimpliPHI battery. And this is even without the heated integrated solution. So you can get these batteries with integrated heaters that stick on the outside of the battery that respond to internal battery temperatures. That is a custom order. But even without this, the SimpliPHI battery will slow down the charge rate in cold weather environments. And by slowing down that charge rate, it protects the battery, but it allows it to run down to lower temperatures. Look at that temperature range there. Most of our competitors limit charging to above 32 degrees Fahrenheit, right? And we can actually slowly charge this battery, right, all the way down to -4 Fahrenheit, right? So we've got a very broad range. Now, it's a very slow charging at that point, right? But as that battery warms up, we can start to, and there's a lot of internal resistance in batteries at cold temperatures. As that battery warms up, we can start to ramp up that charging rate and have an expanded charge discharge range compared to our competitors. This is one of the examples of the kind of innovations that the SimpliPHI batteries have with that BMS in there.
Yeah, Nathan, and lithium-ion batteries are all affected by cold weather during the charge cycle, so it's not unique to us. And what we're seeing in the industry is more and more of these energy storage systems being installed in the Maine, the Montanas, the Minnesotas. So we're really on the a forefront on making these systems work without the need for heaters. These heaters do use power that is stored in the batteries. And so by getting the batteries to work as much as possible without these external heaters is a great advantage.
Yeah,
What
we
we're
keep
seeing,
the efficiency up.
yeah,
Now we do have heaters, right? We
yeah,
have options for heaters as well. And we're showing those in that slide. And here's an example of these battery cabinets. They've got the rain hoods installed. They're installed outdoors in a cold location. And all the batteries that are in these cabinets have integrated heaters that are there. And they're running those Sol-Ark 15Ks that you can see on the outside of that building and supplying power to that factory in the event of a grid outage. And I do believe that factory has solar on the roof as well. This is in Buffalo, New York.
yeah. I do like this install. It looks great. They've kind of put it near the building as well to kind of shelter it a little bit as well. So Nathan, I know we're running a little short on time. We do have Energy Track. I want to leave a little time for question as well.
Yep.
Nathan, we're quickly let's talk a little bit about Energy Track
Yeah,
and what it does
yeah,
and
I'm
what its
showing the wiring
advantages.
diagram here, and we're looking at one of our gateways. This gateway has the ability to take in different communicating batteries, has the ability to take in our 6K inverter that some of our customers have installed. And we're showing just the wiring here for it. It's a relatively simple. I've got two of them right next to me here on the countertop. But let's go ahead and go to the next slide, and I'm going to start showing you some of the things that make that Energy Track nice. So by setting up this system with Energy Track, you have a pretty rapid commissioning process, and unlike some of our competitors, our commissioning can happen in as little as 10 minutes, right? It can be a pretty quick commissioning. It'll give you information about all the individual batteries on your system. Let's go to the next slide. You can set up different levels of accounts too. You might have a homeowner you don't want to be able to do detailed things. They just want to have a view of how their system is doing, how much backup time they're going to have. And Energy Track gives that to them at the battery level. So there's a system owner level, then there's a pro technician level. And if you have a really, astute homeowner, they might want to have a pro technician account, and they can see just systems they're assigned to, but they have full control over that system. And then
Those are the best kind, Nathan.
and then yes, exactly. And then the pro admin can create these accounts, but they can see every account within their systems. That would be kind of your company owner that wants to, or whoever's monitoring the systems. And what it gives you is fleet management. You can see all those systems. For instance, you and I, Daniel, we can see all of the different training systems out there in the field in one spot. It can also give you alerts, let you know if something's down. We're about out of time here, but here's an example of what you could be looking at. So you can see a battery bank on the left side there, and based on the current loads, you've got 157 hours remaining. This is a training system, so we don't really have many loads on it. And then you can see the individual batteries. If you click on those batteries, you get detailed information about the internal temperature, the state of charge, state of health, all these other things about the state of balance of the battery. And then you can see you'll have a view there for the inverter and connected equipment, and then the gateway itself telling you, whether or not that system has got a good internet connection, that kind of thing. Let's keep moving. Sol-Ark also has their own monitoring app, and this is generally pretty good. You just don't get individual battery information out of it. But what you can see is these nice graphs kind of showing, and if you have AC coupled solar, it will show up differently from DC coupled solar. A negative on the battery means the battery's in a discharge. Positive on the battery means it's in a charge cycle. Anyway, there's great information on that. We're running low on time. So
Well, I think a negative is a charge, and then a positive is a discharge.
hopefully I didn't say that backwards, but it
That's it.
sounds like I did. Yes, negative charge, positive discharge.
We do have an installer program.
Mhm.
Anybody who is on this call, if you haven't done a 6.6 battery yet, we do have $1,000 rebate that we can offer you. After you've done your first install, we welcome you to join our IQ installer program. It gives you $100 back on every rebate, on every battery as a rebate. Additionally, we have other advantages. We can promote your company. We can send you leads. We can give you some of those other benefits as being part of that program as well. So please sign up. Let us know. Thank you, everyone, for joining. If you're looking for NABCEP credits, please email energystoragetraining@basco.com, energystoragetraining@basco.com for your NABCEP credits as well. I would also mention, if you are coming to InterSolar, let me know either in the comments right now or email us. I will make sure that you have a wristband for one of our after parties that we're hosting. It should be a lot of fun. It's a bowling party, the Solabration. Please let us know. Again, if you need NABCEP, energystoragetraining@basco.com. Nathan, thank you for being here today. I think this
Sure,
is
Daniel.
really exciting. And do we have some questions?
Yeah, I do want to take the time. Luis, I believe you said, so you asked if we have in-person training. I believe you're in the Bahamas. We will be running training in Miami in the second quarter. So please pay attention to those emails announcing in-person trainings. We'll make sure to reach out to you. I did capture your name. So yes, we have in-person trainings. We'll have a training calendar up on our website soon. We're actually working on that right now. That'll list those trainings, and hopefully we'll be able to search them by location. So we're coming.
Nathan, why don't we go to the Bahamas?
I would love to go to the Bahamas. Actually, I've never been there, Daniel. I haven't been to Puerto Rico in a dozen years, but we are heading to Puerto Rico. We're heading to Miami. Potentially we'll do one in the Bahamas, but I think more likely Miami. And then Verlon, absolutely, we captured your information here. We will send you an email reply. And to the rest of you, thank you for taking the time to be with us. We hope you learned something. And if you were looking for more information about how to program, this is more of an information session. We will have a talk on programming Sol-Arks coming up. John asks, do we have any hands-on trainings coming in Canada? We don't have anything on the calendar yet, but that might change as we work out how to be able to take our trailers. So we have training trailers, and we might offer something. John, I'd be curious as to where you are in Canada, because we might be able to make something work out.
Yeah, Nathan, we didn't mention it, but we have Power Academy. It's our online learning platform that also will tell you all of the location and dates of those in-person trainings. And make sure to email us, and we'll get you those details as well.
Yes, and John, we do have something right across the border in Buffalo, New York, coming up at the end of April. So if you happen to be in that part of Canada that's near to Buffalo, that might be an option for you. If not, we'll be in touch. So thank you, everyone.
Thank you, Nathan. Take care.